Okay, hello everybody. Good evening, all of you guys. I hope that I am audible to you. Please let me know. Please let me know, guys, that I am audible to you or not. Also, tell me that you are with full of energy or not. This is our second lecture of IPC, and guys, as you know that I'm very excited for this lecture, guys. But your excitement is more important than me, so please let me know that you are here, you are watching me live. Please just drop a message and tell me that who is watching me live. Good evening, Anushka. Very good evening. Yeah, Anushka, you were not there in the last class. Were you there in the first lecture of the IPC? You are there or not? Please let me know, guys, that you are able to hear me out. Who is watching me live? Let me know. Very good. Very good. So before start our lecture, we will wait for 2 minutes for others to join our class, because as we know that the initial 4 to 5 lectures are very important for the students. The initial lectures are helpful for building the foundation, so that we can you can say if our foundation will be strong, then we can build our yes. Okay, great. Yeah, so please let me know, guys, that you are here. Please let me know that you are here, guys. If you are watching me on the YouTube, then comment. If you're watching me on our platform, then also drop the message. Okay. Okay, so I think we should move ahead, guys. Right? So as you know that it's our routine practice that we will basically, it's a routine practice that we revise all the things which we discussed previously, guys. Okay, so coming to this online live classes, guys. So it is the GATE 2027 online live classes are there. This is the instrumentation process control, and guys, we are here to move you from basic level to the advanced level, and we cover the entire syllabus through the basic level to the advanced, right? There will be no, if you're looking for a scrap content or if you're looking for unnecessary things, then this is not the right platform, guys. This is the platform where you only get the things which are required, or you can say which are the, you can say the important for the GATE point of view, right? We are not doing here the PhD, and this is not required at all. If you are interested for the PhD, then some of IITs are some of IITs and IITs and the foreign universities are there, guys. So here we are just to focus on the GATE examination, and we will basically doing the content only related to the GATE examination. So guys, let's start the class. And okay, let me tell you the very 2 and 3 points about this online live classes, guys. So as you can see on the screen, that these classes will be in the English language, right? But we are basically, you can say that the students which are basically comfortable with the English or comfortable with the Hindi also, they can join this class because I can explain the things in the Hindi as well as in the English. So there is no issue. There is no any language issue here, guys, right? And there's a recorded backups also. You will get the recorded backups if you missed any class, guys. Okay. So let's start the class, guys. So it's our lecture number 2, and you are studying the instrumentation and process control, which is a very, very important subject, scoring subject for the GATE examination. That was the bifurcation of the topics in the Laplace transform, which we discussed in the last class, guys, right? And in the continuation, we discussed the Laplace transform, what is the definition and what is the mathematical definition of the Laplace transform. Let me clear one thing here, that we are doing the Laplace transform from the point of view of IPC only, right? And in the detail, or you can say in the depth, you will you can say get the Laplace transform lectures in the mathematics, right? Here we are doing here our focus is on the IPC, and we only discuss the Laplace transform which is required. The required content we will discuss here, right? Okay, so again, so this is the definition and this is the mathematical basically your definition. The usefulness of the Laplace is that it converts the, you can say, the differential equations into the algebraic equation, and that is convenient for us to solve the algebraic equation, right? With the help of this integral definition, we already calculated the Laplace of the 1, right? And after that, we calculated the e raised to power 80 Laplace with the help of this integral method. After that, we discussed some formulas which are very, very important, guys, that you have to remember all these formulas. And after that, we discussed some properties of the Laplace, in which first property is the linearity property. Okay, as we know that Laplace is nothing but it is a integral. In the definition of the Laplace, there is integration. Integration is the follow also the linearity property. So you can say automatically the Laplace will follow the linearity property. Means that you can bifurcate the terms and you can basically calculate the Laplace transform of any function, right? Okay, great. Yeah. Okay. So now next will be this was the problem we solved. After that, I just give you this homework and I got the answer from the students on the Telegram channel, and that's good, guys. That's good, guys. Some of you just sent this problem, but some of you did not share the solution. But guys, as I told you earlier, that only the one thing is required to get the best rank in the GATE examination is that just follow your teacher, just follow your faculty, guys, right? Okay. After that, we just discussed the first shifting property, and this first shifting property is a very, very important property, guys. Let me tell you this. Let me tell you this. This is a very, very important property. Property is very simple. Okay, property is very simple. I told you in the last lecture that there is no need to remember all the formulas. No, if you remember the properties, some simple properties, then our purpose will solve. Right? Like, what is the first shifting property related? It means that you are doing change in some domain and you are seeing the change in the another domain. We have the two domain, time domain and the S domain. Yes or no? If you are changing, if you are doing change in some domain, you will face the change in the another domain. What is the basically you can say what is the first shifting property? Just multiply e raised to power 80 with the f of t. What change you will see in the S domain? You will see the change in the S domain S minus a. Right? You will see the a with opposite sign of this coefficient. That's it, nothing else. Right? And with the help of it, we just calculated the Laplace transform of e raised to power 80 cos omega t. Okay. After that, we just calculate the Laplace of the 1. So if you remember this, Laplace of the 1 formula is 1 by s, and we already calculated the Laplace of the 1 and the Laplace of the E80, right? We know what is the Laplace of the 1 and we know what is the Laplace of the E80. We calculated the Laplace of the EAT with the help of the mathematical definition, or you can say integral definition of the Laplace. But there is no requirement to you can say follow this integral definition, but because if we have to do the integration, then what is the point of the Laplace transform, right? Yeah, so with the help of this property we can calculate the Laplace of the EAT. It is very simple that let's suppose that we are our f of t is 1 and just multiply with e raised to power at. It means that what is the Laplace of the 1? It is 1 by s, and if you are multiplying e raised to power at with the 1, what change you will see in the s domain? It is s minus. This is simple as that. I hope that it is clear to you, right? Hope that it's fine for you. I hope that it's fine for you. Okay. Now, second shifting property says, please write down. Second shifting property says that, let's suppose I have a function, guys. I have a function of f of t. Okay. Yeah, I have the function f of t, right? If I'll do the Laplace transform of f of t, then I can say that Laplace of the f of t is my f of s. I hope that there is no problem, right? And I'm saying that a function is gt, which is defined as, I think I should write all these things a little bit. Yeah, but I'm saying that I have the f of t and I am interested to calculate the Laplace transform of the f of t, which is my f of s, right? And my gt is defined as, that it is my f of t minus a at t is greater than a, and it is my 0 if my t is less than a. Is it clear to you? Then guys, then my g of t Laplaces, then what is the g Laplace of the gt? Okay, the Laplace of the gt is that f of s and just multiply with the e raised to power minus as. This is the second shifting property. This is my second shifting property. It is clear to you or not? Okay. I hope that it's clear to you. I hope that it's clear to you. Right? Okay, let's take one example for it and let's try to tell me that what is the answer. Guys, I'm saying that your gt is equal to t minus 2 raised to power 3 if your t is greater than 2, and it is 0 it is if t is less than 2. It means that gt is value is t minus 2 whole cube at t greater than 2, right? It is clear to you? Then we have to calculate the Laplace transform of the gt. What is the Laplace transform of the gt? What is the Laplace transform of the gt? So it is very simple. If you see what is this function? In the t domain there is a subtraction of any constant value, right? So what is my f of t, guys? I think my f of t is nothing but it is my t cube. Yes or no? F of t is my what? It is my t cube. Why? Because in the t domain there is a subtraction of the a, and here value of the a is 2. Is it clear to you? Now what is the Laplace of the f of t? What is the Laplace of the f of t? Means what is the Laplace of the t cube? The t cube Laplace I can calculate with the help of we already calculated the t raised to power n or not? Please let me know. Please let me know, guys, that in the last lecture we have calculated the, do we have calculated already the t raised to power n Laplace or not? If not, then don't worry, it will come. Just write the Laplace of the t cube is nothing, it is my 6 divided by s4. How it will come, don't worry about that, I'll explain to you if I did not. Right? It is clear to you or not? Now it is nothing. It is, what is the Laplace of this gt? E raised to power minus EAS. Laplace of gt is e raised to power minus a. Here a is my 2, so it is my minus 2s into f of s. What is f of s? This is my f of s. This is my f of s, which is my 6 divided by s4. So this is your answer. This is your answer. Yeah. Am I clear with this or not? Anushka, am I clear with this or not? I think that most of you guys are enjoying the Sunday today. Yeah, I can understand it. But actually, the main motto to keep the class on the Sunday is that, as you know, that in the yesterday also I couldn't take your class because my son's health is not good. That's why. So that's why I keep your class today. Yeah, right. So don't worry, जो enjoy कर रहे हैं Sunday वो enjoy कीजिए, there is no issue. You can watch this lecture on the recorded format also, as you know that you will get this lecture on the recorded format also, right? And also when you watching this, whenever you will watch this lecture, and at any point of time, if you will face any problem, any difficulty, just write the message to me on the Telegram, and if you can, if you want to share the snap also, you can share the snap, guys. If I'll be available, then definitely at that point of time I'll give you the solution. Yeah, good evening, Mohammed. Yeah, is it clear to you? Yeah, Anushka, it is clear to you or not, beta? Tell me that it is clear to you or not. And as you know that I'm saying it again, that guys, my energy is totally dependent on you. Okay, so time to time just transfer your energy through the message, right? Okay, yeah. Now the second, you can say the next property is the change of scale. The next property is the change of scale. Okay, now let's see what is the change of scale, guys. Change of scale, it means that scaling means that you are multiplying any constant number to the domain. That is called scaling, right? So what I'm saying that we have f of t, and if we will do the Laplace of the f of t, then we are getting f of s. Is it clear to you or not? Yeah. Let's suppose that I'm multiplying any constant value. If I'm multiplying any constant value in the t domain, so I am multiplying any constant value in the t domain, then what change you will see in the s domain? Then this is the change you will see in the s domain. 1 by a f s of a. Guys, see, I am changing or I am multiplying in the domain. I am not saying that you have a function and you are multiplying that function to, see, please just pay attention here. Just pay attention here. I'm saying that I'm doing this. I'm doing this. I'm not saying that I'm doing this. There's a huge difference between this value and this value. Okay. This means that you are multiplying any constant number to the whole function. That will basically not change your value of the domain, right? It is clear to you. Multiplying any constant number to any whole function is does not make any difference. But here we are multiplying with the in the domain actually, right? So we are basically doing the change in the domain. Okay. Let me clear this with the help of an example. Sir, I had my HPC exam today, so I am in out of the station, sir. I'll watch the lecture later. Okay, there is no issue, Mohammed. No problem. Okay, yeah. So today, there was a HPC exam. Yeah. Yes. That's why you guys are out of station. Okay. Yes. Let's see the example. What I'm saying, guys, I'm saying, let's suppose I have a function f of t is sine t. F of t is sine t, right? It is clear to you. Now, what is the Laplace transform of sine 3t? Right? I'm not saying that what is the Laplace of the 3 sine t. No. Right? This is wrong. I'm saying that we are multiplying in the domain. Okay. So it is very simple that if you are multiplying any number with the domain, then it means that first of all, just calculate your f of s. What is the f of s? F of t, f of s is what? What is the transfer function of sine t, which is called f of s, which is equal to what is the sine t Laplace transform? It is my a divided by s square plus omega square, and here omega is my 1. So my f of s value is 1 by s square plus 1. Now what change you will see in the s domain? 1 divided by a. What is the a? Here a is my 3, and f of s divided by a. It means that in the s domain, where you will see the s, just divide with the a. Just divide with the a. 1 divided by s divided by a whole square plus 1. This is your answer, guys. Again, I'm saying just put you can say a note anywhere in your notebook. It is not s square divided by 3. No. Whatever you will do the change, okay, you will first do that change in the domain. After that, you will apply any operation, or you can say any mathematical thing, like if it is square, that you will keep square, or you can say any power, any power. So just do the change. After that, put the power, whether it is 1 by 2 or 2 or 3, 5, whatever it is. Yes, Anushka, is this clear to you or not? Is this clear to you or not? This is the property number 3 or theorem 3. This is the theorem 3. This is your theorem 4. Yes, it is clear to you or not? Anushka, am I clear with this? Please tell me. Please tell me that am I clear with this or not? Guys, just if you are watching me on the another platform, then you can share this lecture to your friends who are preparing for the GATE examination, because these lectures are very, very important for you, right? Okay. This is my change of scale. Anushka, are you there, beta? Can we move forward? Now, the theorem 5 is, or you can say the property 5 is multiplication by t raised to power n. Multiplication by t raised to power n. Okay. Just see what I'm saying. Again, let's consider my function f of t, and if I'll do the Laplace transform of f of the t, then it will my f of s. It is clear to you? Now what I'm saying, that just multiply with the t raised to power n to the f of t. It means that I'm saying just multiply with the t raised to power n to the f of t. This property is also very, very important. Then in this case, what change you can see in the S domain or in the RHS, in the right hand side, guys. So it will be minus 1 raised to power n. This property is also very, very important. And dn divided by dsn and f of s. F of s. Right? dn over dsn means that it is the differentiation. It is the differentiation, guys. It is my differentiation. Right? It means that we can say that multiplication by t raised to power n gives differentiation. If you multiply t raised to power n to the f of t, what you will get? You will get the results. What results you will get? Differentiation. Right? I know that most of you guys are a little bit confused now, that how do we solve any particular problem related to this. Very simple. We will take an example and after that we will solve that example, guys. Okay. Now, just try to calculate this problem first. Okay. So my example is, let's suppose I have the f of t, guys. I have the f of t is e raised to power 2t. Right? And you have to find out the Laplace transform of t into e raised to power 2t. You have to find out the Laplace transform of t into e raised to power 2t. This is the problem. This is the problem, guys, right? Okay. So see, I have this function L, I have this function, okay? I have this function. You have to find out the Laplace transform of t into e raised to power 2t. How do we calculate it? Very simple. Whatever the properties we just go through, just apply that property. Here n value is 1. Here my n value is 1, okay? So it means that first of all, just calculate the f of s. If you are considering, just pay attention here. If you are considering that f of t is my e raised to power 2t, then what will be the Laplace of the e raised to power 2t? What is the Laplace? Laplace is very simple. Laplace is my 1 divided by s minus 2. It is my 1 divided by s minus a, right? I hope that you guys are aware about it, right? Because yes, in the last lecture we discussed this. Now, just apply this formula. It is my minus 1 raised to power n. N means it is 1. And it is d divided by ds. Here it is my n. It means that n will decide the power of n, the power of t will decide that how many times you have to differentiate the fs. Right? I'll say it again. I'm saying that d raised to power n divided by dsn. What is the meaning, guys? Meaning is that the power of the t will decide that how many times you have to differentiate the f of s. Here at the power 1, then we can say that I have to differentiate this f of s, which is my 1 divided by s minus 2 single time. I think there is no problem, right? So I'm saying So the Laplace of t into e raised to power 2t is equal to what? It is differentiation of this. Differentiation of this. Right? What is the differentiation of this? What is the differentiation of this? The differentiation is minus 1 divided by s minus 2 whole square. Okay? It is clear to you now? Right? It is minus 1 by s minus 2 whole square. And 1 minus sign is already there, then it will be positive. Then what is the differentiation? 1 divided by s minus 2 whole square. 1 divided by s minus 2 whole square. Okay. So this is your answer. Now I'm saying that you can play with the Laplace transform if you have the knowledge of the properties. There is no requirement. See, there is nothing like that. You have to follow this path only. You have the alternate way also. You have the alternate way also, guys. What, sir? You will say that what is the alternate way, sir? See, alternate way. Now, because we are studying the property where we have to multiply with the t raised to power n to any f of t, right? And we have to go with this path, with this differentiation or all that, right? We can do the different method also. If we have t into e raised to power 2t and I have to do the Laplace of it, then what to do? Guys, I have the first shifting property that in which we have to multiply a function to the e raised to power at. So it is something like that. We have to multiply e raised to power at to the t. Then what will be the answer? Just find out the Laplace transform of the ft. That will be 1 divided by s square. If you are multiplying e raised to power at, then what you will change in the, if you are multiplying e raised to power at to the t domain, then what change you will see in the s domain? Just keep the a with negative sign. And what is the a here? It is my 2. It is my 2. So what will be the answer here? It is my 1 divided by s minus 2 whole square. This will be your answer. So it's totally depends on you guys that what do you want, and at that point of time what properties will strike to your mind, right? That is clear to you or not? Just write it and tell me. After that we can move ahead, guys. Whatever the concept I told you in for the Laplace transform, whatever the, you can say whatever the questions I'll give you to for the Laplace transform, please solve those questions, remember those properties, right? You will not face any single problem in the IPC for the, you can say, Laplace transform, regarding the Laplace transform, guys, right? So don't worry about that. As I told you that we will, you can say that we will start the things with the 0 and we will take those things to the advanced level. Okay, so don't worry about that. Don't worry about that. Just follow whatever we are saying. Okay, this is not the, you can say, first time. This is not our first time, guys, where we achieve the, where our students achieve the single digit rank, even the rank 1, right? So just follow whatever we are saying, guys. Okay, now the next property is division by t. So this is my property number 5, which is multiplication by t, and here it is my division by t. Here it is my division by t. Let's see what is the meaning of division by t. So again I'm saying that I have the f of t, right, and the Laplace of the f of t is my f of s. And now in the t domain, we have to multiply the t. You know? I have to divide with the t to the f of t, right? It is clear to you or not? So it means what I'm saying that I have the f of t and you have to divide the t. And now you want to calculate the Laplace transform of this function. It is very easy to remember. It is very easy to remember. See, the multiplication of t raised to power n gives you the differentiation. Now the division of t gives you the integration. That's it. If you remember these two lines, then there will be no problem. So this multiplication of t raised to power n gives you the differentiation. Then this division gives you the integration. Then what will be the value of the integration? Integration s to infinity f of, one second. F of s into ds. So if you will multiply with the t raised to power n, then that will results the, what is the impact? Differentiation will come. If you divide with the t, then it will what is the impact? Integration. If you will multiply divide with the t 2, then you have to integrate 2 times. If it is 3, it is 3 times. Then in the IPC there is you can say there is no use of the double integration, triple integration. So don't worry about that. Where it is what is the requirement? Requirement is only the t raised to power 1. That's it, nothing else. Okay, that's it, nothing else. Is it clear to you or not? Is it clear to you or not? Right? Okay. If I'll take a simple example, then let's suppose I have to find out the sine t divided by t Laplace. What properties I'll use? I'll considering that my f of t is nothing but it is my sine t, and the t is basically divided to my function, right? That's the way I you can say dictate this problem, right? Don't worry, just find out the f of s, because we required the f of s. My f of s is nothing but it is my sine at, which is my 1 divided by s square plus 1. This is the f of s. Now just what is the Laplace of it? Laplace of sine t divided by t, that is equal to integration s to infinity ds divided by s square plus 1. Right? When you solve it, it will come tan inverse 1 by s. This will be your answer. Okay, these are the simple examples which I discussed with you, right? But you can use this property at any point of time at wherever it required. Right? It is clear to you or not? It is clear to you or not, guys? This is your property number 6, or you can say the theorem number 6. Okay, great. Now, what about the periodic function? What about the periodic function, guys? So this is your theorem number 7. And this theorem is basically talking about the periodic function, right? Yeah, Anushka, this is clear to you? Is this clear to you, beta? I hope that there is no problem. I hope that there is no problem. बोलिए। Is it clear to you? Is it clear to you? Is it clear to you? Yes, Anushka. Can we move forward now? Okay. Now, see. Next thing is my periodic function. Right? Periodic function. So, periodic function means at certain period of time, a function gives us the similar value. It gives the that value will be repeated itself, right? That is my periodic function, right? So I'm saying let's suppose f of t has a period of t, has a period t, right? Mean that this function is basically repeat its value after the t times, right? After the t times. So it means that it is very simple that f of t plus t means the value of this function after t times it's same as the f of t. This is the meaning of the your periodic function, right? And what is the Laplace of the f of t? Laplace of the f of t is nothing but it is my 0 to capital T e raised to power minus st f of t dt divided by 1 minus e raised to power minus s capital T. This is the value of the Laplace, right? This is okay, Anushka, there is no problem, right? Okay, guys, am I clear with this or not? So for the periodic function, this is the formula for the Laplace transform. Okay. Now, this is my transform of derivatives and integrals and ordinary differential equations. This is also, guys, very important. Very important in the IPC. There is a huge use of the Laplace transform of the derivatives. Laplace transform of the derivatives. So please pay attention here. Okay, just pay attention here, and that how do we solve all these type problems, right? Okay. So here f dash means the single time differentiation, double dash means the 2 times differentiation, right? What I'm saying, the single dash means the single time differentiation, and the second double dash means the you can see your 2 times differentiation, right? That is clear to you or not? I'm saying that I have, guys, f of t. What is the Laplace of the f of t? First of all, very simple, sir. I know that it is my f of x. Great, we know this. Now I'm saying what is the Laplace of f dash f of t, right? Or I can say what is the Laplace of d divided by dt of f of t, right? So f dash t is nothing but it is my one time differentiation of the function f of t. It is clear to you or not, right? It is clear to you. And similar, in a similar way, f dash is nothing but it is my d square upon dt square of f. Okay, now see, the differentiation of the first time differentiation is s into Laplace of the f of s. Laplace of the f of t minus f of 0, right? Or you can say, I can write this in a very simple language also. That is Laplace of your f dash t is nothing but it is equal to s into f of s minus f of 0. Please write like this. Please write like this. Right? Okay. So let me write first one, that what is the Laplace of the first differentiation, that is equal to s into f of s minus f of 0. Don't worry about that. I'll tell you what is f of 0. What is the second as Laplace transform of double derivative of f of t is what? It is my s square f of s, okay, minus s into f of 0 minus f dash of 0. F dash of 0. So f of s, we know that it is the simply Laplace transform. Please pay attention here. There can be a little bit confusion here. So for that purpose, I'm saying that please put attention here. What I'm saying, I'm interested to find out the Laplace of the first derivative of the f of t. I'm not interested to find out the Laplace of the f of t. Multiple times I calculated the Laplace of the f of t. Now I'm interested to find out the Laplace of the first derivative of the f of t. That formula is equal to s into f of s minus f of 0. What is this f of s? F of s is nothing but it is the Laplace transform of the f of t. So it means that if we want to calculate the Laplace of the first derivative or second derivative or third derivative, then we require the Laplace transform of the f of t. Because in the formula of the Laplace of the first derivative, there's a term that is f of s, and f of s is my Laplace of the f of t minus f of 0. Now what is f of 0? F of 0 is the value of f of s at 0 value. It means that what is it is showing the initial values. F of 0 is showing the initial values. And you will find the practical implication of this f of 0, of these initial values. What are the meaning in the context of the IPC when we discuss the IPC. Now what is the Laplace of the double derivative? It is my s square f of s minus s f of 0. F of 0 means, then it means that you are putting s equal to 0. In the f of s you are putting s equal to 0. Minus f dash 0. It means that you have f of s and you are differentiate the f of s, and now you are putting the s equal to 0. Am I clear with this or not, Anushka? But I'm clear this, what I'm saying, it is clear to you or not? Please tell me that it is clear to you or not. Right? So these f of 0 is showing the initial values. So I can write, this is the, you can say, if I have the Laplace transform of the f of n, means the n means the n times of the differentiation, okay, n times of the differentiation, then I can write s raised to power n. It is something like that, Laplace of dn over dsn, dn means n times differentiation of the f of t, nothing but it is s raised to power n f of s minus s raised to power n minus 1 f of 0 minus n raised to power 2 f dash 0, like that, and it is my f of s n minus 1, right? into 0. It is clear to you or not, right? But there is no requirement of, you can say, the third time derivation, your triple time, four times, fifth time. Our requirement is only 2 times. So just remember these 2 formulas. These are important for us. These are important for us. Remember these formulas, guys. It is clear to you or not? It is clear to you or not? Please let me know that it is clear to you or not. It is clear to you or not? Right? Okay. Done. So these are the initial values, guys. Okay. These are the initial values, nothing else. And when we discuss these values and how what is the practical application of all these things, then you will find out that what is basically the requirement of all these. Okay. And you can say most of the time we will take initial value 0, and why it is like that we will basically cover when we discuss the IPC. Okay. We are here only discussing the mathematics, which is a very useful tool for us. Now this is my theorem 3. It is my Laplace transform of integral. It is my Laplace transform of integral. In the first 2 examples, we just discussed the Laplace transform of derivative. Here we discuss the Laplace transform of integral, right? If we have Laplace of, let's suppose I have the f of t, and I want to calculate the Laplace transform of the integration of the f of t. It means the Laplace of integration 0 to t of f of t dt is equal to Laplace of f of t is required, that is equal to f of s, and it is my f of s divided by s. F of s divided by s. Okay, just forget about it. Forget about it, because when we discuss the Laplace inverse, then we will cover this, right? So just forget about this. Just remember this formula. Okay. Correct. This is my Laplace transform of the integral. Done. It's done for you. Great. Okay. So let's take a very simple example for it. Let's suppose I have to find out the Laplace of integration of 0 to t sine 2t dt. Okay, sine 2t dt. It means this is my f of t. What is my f of t? F of t is my sine 2t. What is the Laplace of the f of t? Laplace of f of t is my 2 divided by s square plus omega square, that is 4. Right, put this formula. I think we will have our answer, that is f of s is my 2 divided by s square plus 4 and divided by 1 by s. So it is my, so this is my answer. 2 divided by s into s square plus 4, that will be the answer. Very simple. Very simple. There is no requirement of doing any integration or all that, right? There is no requirement of doing any integration and all that, right? I hope that it is clear to you. I hope that it is clear to you guys. Okay. Am I clear with this? Am I clear with this? Yes or no? Okay. Now, this is one of the theorem which is very, very important, guys. This is the one of the theorem which is very, very important. Means that you will use this theorem in throughout the IPC. Throughout the IPC. So please, you can see that put your attention here. 100% attention, 100% focus should be here. Guys, final value theorem. It is a very, very important theorem, right? So first of all, let me tell you that what is the use of it. What is the use of it? The use of it is to find out the final values. To find out the final values, right? In what context I'm saying final values, I'll tell you when we are discussing and when we enter into that context. If I have any function and I want to calculate the final values of that function, then I will use the final value theorem. It is clear to you or not? So it is to find out the final values of the process. Final values of the process, you will use the final value theorem. Now what final value theorem says? So as you know that I have the two domain, I have the f of t, and I have the if I'll do the Laplace of it, then I have f of s. So I have f of t and I have f of s. I have the function value in the t domain, and I have that value of that function in the s domain also, right? Guys, in the IPC, it's not necessary that always we have the function the t. Wherever it required, I can calculate the f of t into the f of s. Wherever it required, I convert the f of s into f of t. In the Laplace transform, as you can see that we convert the f of t into the f of s. In the Laplace inverse, we convert the f of s into the f of t. So it is, you can say, not mandatory that I have only the I have only the value of the function in the t domain. It can be in the any domain, right? It is clear to you. So final values. Final value means that we are calculating the function value at t tends to infinity. Means limit t tends to infinity. I have the function of f of t and I want to the final values of this function. There is no problem. Just put the t tends to infinity. You put this limit t tends to infinity, you will get the value of the function, or you can see you will get the final values of this function. It is clear to you or not, right? If I have the s domain function, then also I can calculate the final values. So this value is equal to, just multiply s to the f of s and limit s tends to 0. So these two values are same. These two values are same. As you know that s is my 1 by t unit wise, right? It is unit wise 1 by t. It means it is reciprocal of the t. So if it is in the t and I'm interested to calculate the final values, don't worry about that. Just put the limit t tends to infinity. And if I have the function of s, then first we have to multiply with the s and I have to put the limit s tends to 0. This is my final value theorem. This is my final value theorem, right? Because these final value theorem utilizes the limits, then it is so obvious that these limits should be exist. These limits should be exist. Right? And there's no requirement to check that limits is exist or not, right? And wherever it required in our, as you can say in the IPC context, the limit is already existed. Yeah, but in the mathematics, the that in the mathematics point of view, they can you can say that ask that the limits existed or not, what is the value and all that. Okay, but for the IPC आपको requirement नहीं है limit check करने, right? Very simple. I'm asking a question. I have a question. Your f of s is, let's suppose, s plus 4 divided by s into s plus 1, s plus 2 and s plus 3. This is your f of s. Find out the final value. Find out the final value of this function. Because it is the f of s, just put this value. Just utilize this thing. Means first we have to multiply with the s to the f of s and keep limit s tends to 0. So first I multiply with the s to this whole function, that is my s plus 4 divided by s into s plus 1, s plus 2, s plus 3. This s and s gets cancelled. Now s tends to 0, so this will be 0, this will be 0, this will be 0 and this will be 0. What is the final expression we will have? It is my 4 divided by 1 multiplied by 2 multiplied by 3. It is 6, 4 by 6. It means it is my 2 by 3. This is your answer. So what is the value of this function 2 by 3? What is the value of this function 2 by 3? Very, very important, right? It is my very, very important. Very good, Anushka. Very good, beta. Very good. Very good. Right? In the similar way, you have the initial value theorem. If I'm interested to find out the initial value of the process, then I will use the initial value theorem IVT. Then I will use the initial value theorem IVT. It is also very, very important. Simply in the t domain, just put limit t tends to 0. Very simple. Limit f of t is my t tends to 0. If you are interested to find out the values of the initial values, that will equal to, that will in the s domain, first of all multiply with the s. First of all multiply with the s to the f of s and limit, I think you know, t tends to infinity. S tends to infinity. Am I clear with this? S tends to infinity, right? Right. So limit, you only one thing which is required to remember, that in the s domain, first we have to multiply with the s and limit should be opposite to the time domain. That's it, nothing else. What is the use of it? What is the use of it? To calculate the initial value of the process. Initial value of the process. That's it. That's it, right? It is clear to you or not? Okay. Let me take an example of it. Very simple example. My f of s is what? It is my s minus 1, s plus 1 divided by s into s plus 3, s minus 4. Find out the initial value theorem. Find out the initial value of this function. Very simple. First I have to multiply with the s minus 1, s plus 1 divided by s into s plus 3, s minus 4. What is the limit, guys? S into f of s. Limit s tends to infinity, right? It is clear to you or not? So it is my thing. Now see guys, you have to you can say that you should know that how to apply the limits, right? Do not put the s tends to infinity. Do not put here s to infinity. Don't put s tends to infinity here. Okay, that's not the way to find out the limits, right? Do one thing. Just take out the common s. If I'll take out the common s from here and here, This will be s common, then it will be s cube into s minus 1 will become 1 by s, 1 minus 1 by s, and it will become 1 plus 1 by s divided by similar the thing you have to do. It is my s cube into s cube 1 plus 3 by s, and it is my 1 minus 4 by s. Now if s tends to infinity, it means 1 by s tends to 0. S cube 0, it is 0, it is 0, it is 0, it is 0, then it is my 1, and that will be your answer. That will be your answer. Okay, so you'll find some question based on all these things, guys. So just calculate all the questions which I'll share to you today. It maybe you will get the questions by today or tomorrow. So for today's class, it's done from my side, guys. In the next class, we will start the inverse Laplace theorem. Okay, we'll start the inverse Laplace transform. Okay, so I hope that you enjoyed the class, right? And once again, I'm saying that if anybody is preparing for the GATE, specifically in the chemical engineering, guys, then this platform is, you can say, if you want to achieve something, this platform is right for you, right? And here we will take your, our journey is basically, you can say, from basic level to the advanced, and we will cover up the entire syllabus with, you can say, with the you can say depth. Okay, so guys, that's it from my side. I hope that everything is clear to you, but still if you have any doubt, guys, our paid student can message on the Telegram channel, and the other students can drop the your doubt on the comment section. Okay, and till then, bye bye and take care. I hope that you get everything right. Thank you so much. Bye bye and take care.